So, quick information about my background. I'm working at the ISS, that's the company called Integrated Scientific Services. I'm working there as a software engineer, part-time consultant, and through that I've come into contact with different software projects and customers that try to make their products or processes compliant with the IEC 62304, the Software Development Lifecycle Standard for medical device software. So in that regard, I'd like to first give a bit of an introduction to the standard for those that need a refresher or haven't seen it so far. And then we'll always try to add some real world experience or perspective of things I've encountered during my work with the standards and with the companies where we've provided some assistance in getting compliant. So before we really start, there are multiple versions of the standard. If I'm talking about this standard, it's the current, well, the so-called current one, the edition 1.1, that's based on the old one, the edition 1.0, with some amendments done 5 years ago. There are some issues with edition 1.0 is still being the harmonized standard for the MDD, but the MDD is on its way out. So for us, we just take the state of the art, the edition 1.1. There's a new one that's being worked on, but it's been worked on for quite a while, so it's not yet relevant. So I'd first like to introduce you to some basic concepts regarding the standard and maybe regulated software development as such. As far as the standard is concerned, software is anything that is executed on a processor or by an interpreter. For me, it's usually the thing I cannot touch, but which makes the thing I can touch do the thing I want, or at least the thing I tell it to do, which is not necessarily the same as any programmer can tell you. So the most obvious examples are application software on a PC, mobile app on a phone. And for some people, a bit less obvious is firmware code embedded into a device, maybe semi-permanently programmed into a microcontroller that's never seen by the end user. And it's a bit of a controversial topic. It also includes FPGA source code. So the FPGAs are configurable pieces of hardware that are still in a way programmed. And this is something that has been clarified with the amendment. But it is a bit of a controversial topic. So essentially, our software, medical software, can be divided into two major groups. We have embedded software, also known as medical device software. That is software that is part of a physical medical device. So it is designed for a specific device, it runs on a specific device, and it's not generally available outside of the device. Then we have, that's a newer field, and with medical apps, one with quite a bit of growth. We have standalone software, also known as software as a medical device. That's software that is not part of a physical device and that is designed to run on generic hardware or software platforms. And important, software in itself is the medical device. If I talk about platform, that's basically the hardened software that's required to run such standalone software. Usually that's the operating system, device drivers, system libraries, something that's not delivered by the legal manufacturer. There's one complication with the terminology, the Medical Device Coordination Group. That's the part of the European Commission that makes guidelines for such things. For some reason, it uses the term medical device software for both embedded and standalone software, so potential adding some confusion. Another important concept that's mostly specific to the standard is SOUP. That's software of unknown provenance, which essentially boils down to third-party components that haven't been developed by the legal manufacturer or not according to one of the recognized lifecycle standards, in this case the 62304, or if it has something the legal manufacturer doesn't have the documentation for and still doesn't know if it's been done compliantly. Third-party components, SOUP in this case, are usually integrated into a product to reduce development time and or not to reinvent the wheel, because most developers don't like to do that. The standard does define additional requirements and activities regarding the use of SOUP. So unlike in non-regulated fields, the use of SOUP, the use of third-party components, incurs additional efforts and costs. So it's not as suitable to reduce time and costs as in non-regulated fields. The standard is about product life cycles, and the product life cycle is essentially the eternal cycle of planning, requirements engineering, designing the product, implementing the product, testing, as we've learned in the talk before, analysis in the field on how the product does not meet the customer requirements, or if there's any additional requirements we can satisfy to add value to the product. The first loop we usually call development. The subsequent loops we usually refer to as maintenance. Once a product is no longer useful, it's decommissioned, depending on how it's depending on its form. This is by pretty much decommission the device. If it's a service, by switching it off, etc. There are some requirements, but that's something for another time. So the life cycle is pretty much the same for medical devices, except the central part everything revolves around is risk management. So everything we do is usually to reduce the risk for the patient, reduce the risk for the operators, that's important, and actually any person or even the environment that could be harmed. There's also a sprinkle of post-market activities, as we've heard in the talks before, but otherwise it's essentially the same. If we talk about development models, these are ways on how you actually implement software, how you do this. It's been mentioned before, we have the V model, we have waterfall, that's one of the first one, and nowadays there is pretty popular is agile and so-called iterative models. Not, as with most things, not all models are suited for all environments. In regulated environments like medical devices, automotive, aerospace, some models are seen more often than others. And one thing to be aware of, especially if you assist companies transforming from non-medical to medical company, people can get a bit attached to a certain model and can get quite a bit religious about them. So they have a non-fact-based opinion about certain models. So the IEC 62304 at a glance, the standard is a so-called process standard. It defines requirements to the activities of the life cycle, of the development, of the maintenance, and not to the product itself. So it doesn't tell that the product needs to be round, green, whatever. Evidence of the correct application of the standard is done by inspecting the documentation. So if the activity is performed, it should result, or it, well, pretty much should result in a certain amount of information that's put in into a document. The standard does mention multiple times that it does not want to enforce a specific development model, but it defines a set of activities that are in themselves dependent on the output of previous activities. So there is a bit of a chronological order to activities. So you're not completely free to do what you want. The standard, if you look at the whole regulatory and normative side, is somewhere, in our case, in the lower right edge, and is here to help us achieve certain, or to fulfill certain regulatory requirements. I usually show this slide just to get over the complexity. So more practical is if you look at our standard like this. So we have a lot of standards that are on product level that are essentially wrap around our standard, and we software developers work somewhere in the center, hidden away from all the other stuff that wraps around us. We have some interfaces to usability engineering and risk management, actually quite a lot of that, but we're hidden away. So the view before was for embedded software, and for health software, for standalone software, it's pretty much exactly the same. There's one standard that mostly differs. In this case, for all the app developers, they should also apply the 82304. So just don't try to read this, it's way too small. That's just to give an impression. If you look at this whole product development as a V model, the software development standard only covers the lower part. All the other parts marked in red, they're outside the scope of the standard. So you can't develop a compliant medical device with by just following this standard. You need other things. As mentioned before, there's a high focus on risk, and the standard revolves around the risk-based approach to its activities. For this, the standard defines 3 software safety classes, A, B, and C, where a software safety class of A means the software can cause no injury or damage to the health of a person, be it the patient or the operator or anyone else. Class B would be for non-serious injuries that could be caused by the software, and Class C for death and maiming the patient or operator by the software. So the software itself can, of course, not directly harm a patient. So if the software controls anything that would lead to that actually does the harm, like a robot arm or even a dosage recommendation for some let's say cancer treatment, it's still the harm that the software classification is about. Software safety class applies usually to the software system as a whole, but may optionally be applied to individual components or groups of software. That's usually important if you have a lot of low-risk components, maybe like planning things for, if you have a clinical information system, you have a lot of things that aren't medical or are for low-risk stuff, and you also think things that are for high risk, like dosage for cancer medication. So if you have a lot of low-risk stuff, you can, if you do it right, have a lower safety class for such components. The really important thing is that the software safety class is defined by the potential harm emanating from the software. It ignores the probability of such. So we don't base it on the risk, but the potential harm. And there's one thing that's usually leading to some confusion. There are multiple classes where a medical device can fall into. We have the software safety class, that's the part we're concerned with. And we have the big part, the medical device classification for the whole medical device, at least in Europe. And for software, we also have the level of concern by the FDA. All of them are independent, but all of them are risk-based, so they should kind of correlate a bit. As again, for the activities, They are controlled by the software safety class, so we perform the activities based on the risk the software poses. So for class A, that we have the least amount of activities. Class B, we have, well, I would say middle ground, but it's more likely like more like class C. And for class C, we have to do everything. The difference between class B and C is shrinking with every addition of the standard. So in the end, they're most likely they can drop the class B in the future sometime. So to determine the software safety class, you actually need input from the risk management, because that's not something you tell the developer to do. Like, hey, you need to decide on the risk safety software safety class for your part because you're the software developer, you know best. Now it's actually based on the residual risk for the product, on the residual risk of software risks. In this example, that's one of how we do it at the ISS. We have those that are that know risk management. It should look familiar to them. We have severity classes, means how bad is the harm for the patient. We have probability classes, means how probable is that the patient will be harmed. And residual risk is the risk after we have risk control in place, after we have risk mitigation measures. And in our case, we still have 8 software-related risks left with a severity of C, which in our case makes this a Class B, software safety Class B product. As far as the classification goes, it should be done as early as possible because it determines the activities of the other parts in the standard. If it's not known, you technically should apply Class C. Practically, you can also, if you feel lucky, start with Class B, and then if your guess is wrong, do all the different fix up. Well, retrospectively, do all the stuff you didn't do that you should have done. As I mentioned before, the classification is based on the residual risk, but we may only consider risk control measures that are external to the software, because the standard essentially assumes that if the software fails, it does so catastrophically, and which would negate any software-based risk control measures. So that's something to keep in mind. There's also a thing that often leads to question and confusion, because for this classification, the standard states that the probability of a software failure shall be assumed to be 1. This sentence only concerns software classification. It doesn't have anything to do with the rest of the risk management or general probability of failure. But it's something that's asked quite often. Small example about how you can have different classification for different components. In this case, we have mostly Class C software system with some small components that are Class A or Class B. But the important part is, if you have lower classed software components, you may need to make sure, at least provide a rationale for it, that there is a segregation between the lower class and the higher class components, because if your lower class component can fail and adversely affect the higher class, then well, it can't be classed and lower, because it would obviously lead to a risk that's higher than it was classified for. Also, something to be aware of is that if you have software-based risk controls for anything, the risk controls take the safety class of the risk they're controlling. So finally, to the processes, I'll try to keep this one short. We have 5 major processes. That's software development, software maintenance, software risk management, configuration management, and problem resolution. All of them kind of boil down to pretty much these 3 steps. You plan your activities, you do them, you verify that they have been done, and then that they have been done correctly. If not, you fix what is broken. So software development is pretty much that. If you look at the more detailed stuff in the center, we have planning. Then you figure out what you need to do by gathering the requirements. You design the stuff by starting by the architecture, detailed design, implement it, and test. In the end, if everything's tested and integrated, you make a software release. So that's pretty much straightforward with any software development process. Software maintenance process is pretty much the same, except you don't have a software development plan, you have a maintenance plan, and your requirements come from problems that have been found or changes that have been requested by marketing, customer, or whoever. Otherwise, it's the same. Risk management. This is part of the overall risk management of the device because the 62304 mandates the use of the 14971 risk management standard. There are some exceptions, but they're they're not worth talking about. It adds the 62304 adds some software specific perspectives and tells us where exactly to do what. So most of the things are the same, except that for software changes, we need to analyze the impact on the patient risk, if there's a new risk, if an existing risk control measure is affected, and so on. And one really, really important part is the software developers are not risk managers. Even if you have a software-only product, risk management is not done by software developers. You need a risk manager for that. The software developers they must be part of the risk management team as experts, but they're not the risk managers. So configuration management process, that's simply put, makes sure that we know which inputs led to the output, namely the finished software. So if you do configuration management, essentially for a software release, we basically make a snapshot of all the source code, all the environment, all the documents, all the requirements, and all the things that were used to implement the software, including all the required tech file documents. Yeah, I think that's enough for that. So the problem resolution process, that's usually a pretty important one. That's when you find problems in the field, when some customer or even your developers find a bug, it tells you how to process the bug. So you prepare a problem report, most often it's just a ticket. You look at the problem and analyze the problem's impact on safety. That's again risk management in part, and not only the developer. The developer can tell you how the software is going to fail, but how this can harm the patient, that's usually outside the scope of the software developer. Inform relevant parties. Well, that's obvious. You tell everyone that needs to know that there is a problem. This can go up to Swissmedic essentially. Then to fix the problem, we create change requests and kick off the maintenance process. Important, as also mentioned before, you verify the problem resolution, so you test and you add regression tests to make sure that the bug doesn't creep back in. Especially if you work with software branches, it can easily happen that if a developer merges back some changes from a different branch, that suddenly you undo someone else's fixes of a bug. That has happened and it will likely happen again. And yeah, post-market part is you analyze problems for trends. So are you suddenly or are you over time getting more bugs? So maybe you have new developers, or you have a stressy situation, overtax them or something like. Analyze the problems for trends to figure out if there's a greater underlying problem. And well, pretty much all of these activities can be handled by a properly configured ticketing system. At least that's how we do it. So chronological order of these processes is usually not quite how you see it in a standard. Risk management obviously runs all the time. Software development pretty much runs as such till the first release, obviously identified by the version 1.0, and after that we have software maintenance. Configuration management, to be fair, often only happens in shortly before the actual release. That's usually obvious if you get a lot of documents that are all signed and released on the same day. That you push all the releases off until the very last moment because there's always something to change, some dependency, and so on. Problem resolution we often see is only started at the verification, because before you just fix the problem, you don't actually look at the detail during development. But if you have a release candidate, it's sometimes easier to analyze the problem if it poses a patient risk that's not acceptable, and if not, just add a ticket and fix it in the next release. So that is if you go against the recommendation from Herr Degen that you have fixed release dates and need to get something done by the time, regardless of it being broken or not. That's sadly a fact of life, which should be avoided, but yeah. Okay. So for me as a consultant, I usually see different types of projects. That's the obvious ones. We have greenfield versus brownfield. Greenfield is before the project has started. Brownfield is you come in after the project has started and is usually already stuck in the mud. Then we have different types of companies. We have motivated companies and unmotivated companies. Get to that later. We have, in this regard, startups that have as a goal fast exit as being bought out by Google. Or some are in for the long haul. They try to become a legal manufacturer. And of course, with startups, actually also with big companies, you have companies that apply a development process, and we have companies that go something like, ooh, we have something like Scrum-ish, yeah, the tool guided us. And as a consultant, you're usually only called when the project's already stuck. So we have, I'm getting a bit short on time. I'll skip the detailed examples. Just the university project, that's stuff that's usually unmarketable because that's done by non-developers, has high turnover, not qualified to do this. We have startups that are motivated. They just want someone to write documentation and not do anything development related anyway, because they're usually on a tight budget and want to sell the company without actually getting the device out. Yeah, I'll skip this. So let's go to things that work in the field. So obvious, if you are a company, if you start a product, what's going to work is if you do development right from the start. If you are compliant right from the start, that's usually with experienced developers that start a new product. It is possible to do retrospective activities for a product that's already started and suddenly became a medical device because add new functionality, etc. But requires some motivated parties, because you don't just add documentation, you actually need to retrospectively do some activities, and it will not be painless. What interestingly also works is if you are a startup, if you have a product and it turns out to be a medical product and you just can't become compliant in the time you have left or the budget you have left, you can remove the medical functionality and market the product as lifestyle product. And if it sells, you can use the time and money to get up to spec with regulated software development and add the medical product, medical functionality back afterwards, and try to market it later as a, well, release it as a medical product. What also works, that's encouraging for many startups, is you can move from pure agile development to IEC compliant development. So what usually doesn't work is ghostwriting. Companies that just want you to write documentation to look like they're compliant, because any competent auditor will smell that from 10 miles against the wind. What usually also doesn't work is university becoming legal manufacturer, because that's, from an organizational standpoint, tricky. Agile development doesn't remain pure. Usually you can have agile development, but you have to add some additional tasks that the standard requires. Important, forcing software processes on developers that don't want to use process, or don't, mostly because they don't understand the reasons for them. They might leave the company, they might not work as planned, or it often doesn't work. Also, for some of the startup companies, replacing consultants until you find one that actually tells you that how you do it now is okay. Usually doesn't work, because if the first 3 told you you need to do some changes, then it's most likely the thing that you need to do. So one important thing, I'm stealing some question time now. One important thing is the mindset of the software developer. I can't stress that enough. That's a pretty big human factor and pretty important. So the developer needs to be sorry, got interrupted by phone. Needs to be aware that what he does here is not writing software, but it's trying to achieve the intended use of the medical device with minimal risk to the patient. So it's a bigger thing. So, and the processes are here for a reason, and not just to torture the developer. And sorry. And software development is part of a whole, so we don't have lone gun developers. So if you think something in the software design needs to be changed, something it would be pretty neat if you make it this way. Just don't do it without talking to all the other guys, because a certain way to do something might be the result of a lot of risk management activities. So if you do it differently, you might open a kind of worms regarding risks coming from the software or usability stuff or so. So developer needs to be aware he is part of a team. The same thing, design changes are not local. So if you change something, other teams might be affected. And really important is the whole error handling. Software in a non-medical field usually is, you show an error message, you crash, or you exit the application. If you develop software for a pacemaker, that's not going to fly. So you need to be aware that error handling is really important. So you might need to think ahead about failing, how do you call it, have a soft fail, go into a degraded mode while still providing the essential performance and all that. Also important part is that soup is not free. There are a lot of shiny, sexy frameworks and components libraries out there, but each one incurs a cost in the maintenance, in the vigilance, and so. Also, soup usually comes with a license, software license, especially for open source. So be aware that you can't, that you need to check the license and make sure it's compatible with what you're writing. Not that your whole medical product suddenly has to become open source. And in that regard, that's about refactoring. Technical debt is if you create a shortcut, plan to fix it later in a subsequent release. With medical software, this means you have to do a lot of more testing, because if you refactor later, you touch a lot of parts of the software you wouldn't need to touch for just minor changes. So if you need a lot of refactoring, you will do a lot of work and a lot of testing. So these are essential things that are usually asked questions. Quick look into the crystal ball. Slightly relevant for software development is cybersecurity. It's becoming more and more important. There are some draft standards that are relevant to 62304 users because they intend to extend the 62304 processes with cybersecurity activities. The major one is 80,001 part 5-1. This should be published, if everything goes according to plan, mid next year. It's essentially, it's a pretty nice one because it just attaches all the cybersecurity activities to existing 62304 processes and activities. The edition 2 I've mentioned before, it's been in development for quite a while. The second draft of the second edition has just been rejected by the committee, which puts the current estimate for the release date again also for the middle of next year. And I fear that's optimistically. So that's pretty much it. We can move to questions.
Thank you very much, Mr. Steck. If you pull up the chat window, you can see that there's several questions that have been posed. I'll try to state them chronologically here. First, Anna Borman asked, can you please expand on how to define the class of a software? Like what tools do you suggest for classifying your software?
Quickly trying to find the chat window. Okay. So tools, we don't, at our place, we don't use any tools as such, except the ones we implemented as our processes, as our risk management process. We have a risk analysis where we mark any risk that is caused or where is a contribution from the software and basically filter them for that. So there's no nice shiny tool for that at least that we use.
Next question from Al Christie. What do you find is the most effective, efficient approach of applying change control using agile methodology?
Whoa, ooh, that's kind of tricky one. Yeah, pretty similar to other methodologies. With us, with agile, that's always pretty company dependent on how the processes already exist. With us, we usually do it ticket based, where everything has basically every change has to lead back to a ticket which has to have a reason for existing, like there's a change request from the whole product, there's an issue that came through the software change process, software problem resolution process. But all in all, it becomes a bit tricky. Like if with agile, what you often find is that that the company works with user stories, and that's often a bit tricky if you have a bunch of user stories distributed across tickets and you have to estimate the impact of a change on all the other on the existing software system. So we usually kind of try to encourage companies that use agile processes to move to a bit requirements documentation based requirements management and not user stories. So okay. Sorry, it's a pretty big topic. I think we need to take that to a separate discussion. I'm sorry.
All right, but a ticket system is a good start.
Yeah, that definitely.
Okay.
But that's also nothing new to agile development because tickets are neat. We can use them for almost everything.
Excellent. So next question. Can you say what approach is used for verifying risk control measures and evidencing traceability?
Okay, I'll start with the traceability. Well, traceability is with us done with the normal development process. We have for every well, we start with the user requirements, and every requirement at the system level is derived from a user requirement or another stakeholder requirement. So from this, then we derive the software requirements, which also all need to be derived from a requirement at a higher level. And this goes all the way through, including testing. So if you write a test, you link that to a software requirement or to a system requirement. So you have a traceability there. And our process, or actually most processes, ensure that each requirement, each must requirement, is implemented in a software. So if you add your software control, your risk control measures to the software requirements, you already ensured at the process level that they will be implemented. And because every requirement will have to be tested, you already ensure that it will be tested. So that's just to do the one part, the part that it is implemented. Regarding the efficiency or the effectivity of a risk control measure, there are multiple ways. It kind of depends on the risk control measures. There are those that are, well, basically can be mathematically proven or can be shown by testing. So if you have reasonably good testing, you can say it never happened during testing. The code review showed us we cover all the cases that can happen. So in this case, we can in some ways consider it effective. Others are post-market, where you, if it never happens in the field, it must have been effective. Okay, that's a bit mean one. And then there's the usability related ones. That's where we actually do usability tests, which validate the product. And if the user, if you have software-driven use error scenarios, if you have a set of test users and none of them actually falls into the trap or does the error, you can with a certain probability say it has been effective. There are some guidelines from the FDA about how many users you need to get a certain security about usability tests. Also rather big topic, so I'd like to cut it off here.
Yes, I'll take one last question, and I think this is one that pops up every now and then when it comes to 62304. It has to do with the probability, whether we only look at the probability of harm as 100%, or if we separate probability of occurrence and probability of harm and set one of them to 100% and let the other one be variable. Do you have an opinion on that?
Quickly reread the question, sorry.
So reading it out from the chat, by investigating a software problem after a software test, are you considering by the risk analysis that the probability of harm is 100%, or that probability of occurrence is 100%, but the probability of harm can be less?
Okay, I see. The probability of occurrence is technically the probability of harm in our terminology. What you have is the technical probability, the chance that the patient comes into contact with a hazard, and the medical probability, the chance that in this case there actually is the harm, and that the harm actually occurs when the patient comes into contact. So if you multiply those, you get the effective probability. So that's the one we use. We don't just go for the technical probability, but we really go for the probability that there will be a specific harm. This also because for a certain technical probability, there can be different harms, especially if you, for example, have a medication decision support system. Depending on the medication you have and the dosage error you have a pretty wide spread of harms that can happen from feeling nothing at all to dropping dead. So as far as we are concerned, we only go for the harm, the probability of the harm actually occurring.
Okay, I will have to cut you short there. I hope that you can answer the residual questions in the chat. Otherwise, I hope that people can contact you. How do people get in touch with you, Matthias?
The email address is published on the front of the presentation. Well, you will see it when we distribute it.